Hello and welcome everyone to the FlytWare webinar on digital twins in warehousing. So, fueled by developments in the Internet of Things, big data, artificial intelligence, and augmented reality technologies, the arrival of digital twins has reached a tipping point where the physical and digital worlds can be managed as one. Led by engineering, manufacturing, automotive, and energy industries, digital twins are already creating new value across industries. Our objective in this webinar is to help you answer how the warehousing industry is changing with the adoption of digital twins. My name is Ajinkya and I am part of the business development team at FlytBase. And we have my colleague Will Stavenza, who is the Director of Customer Success at FlytBase. He is based out of Greensboro, North Carolina. Will is an aerospace engineer with background of over 20 years in engineering, technical service management, and continuous improvement in operations and logistics. So quick introduction about our company. We are FlytBase. We are the world's first Internet of Drones platform. FlytBase, with its drone agnostic software, enables intelligent automation of drones for a variety of drone use cases such as security surveillance, emergency responses, asset inspection, and warehouse management. With this, I hand it over to Will to walk you through today's topic. Over to you, Will.
Thank you, Ajinkya. Good day, everyone. My name is Will Stavenza. As Ajinkya mentioned, I'm the Director of Customer Success here at FlytBase. I'm based out of Greensboro, North Carolina, and today I'll be sharing some insights and examples about digital twins in warehousing and how it can transform supply chain as we know it today. At the end of the webinar, we will open it up to some Q&As, a Q&A session where either myself or one of my colleagues here in the team will assist in answering your questions along the way. So, let's begin by understanding what is meant by the term digital twin. We can think of it as a dynamic way of replicating an operational physical environment. So the concept of a digital twin, as it has been around for at least 10 years in a product life cycle management, product service, and even in manufacturing. Now, I'll give you an example. Today, in the field of mechanical engineering, engineers first create a computer CAD model of a part of assembly based on a set of actual dimensions. Then the engineers perform a computed simulation to test the object against various conditions, such as temperature, vibration, external loads. This allows companies to quickly evaluate certain performance characteristics of the products without necessarily spending a dime on or physically testing or breaking or damaging the product to test its limitations, right? So digital twins, in a way, they work in a similar manner. The difference now is that rather than engineers using actual dimensions, we are using a large amount of data collected by various digital or physical interactions with the product. Now, this means that we can now create dynamic virtual environments that allow us to accomplish certain tasks, such as, let's say, locating a pallet inside of a warehouse without actually needing to physically search for it. It also allows us to simulate optimal or worst case scenarios so that we can optimize our operations in a cost-effective manner. There are already a number of large companies using and benefiting from the implementation of digital twins to visualize and test new physical operational models. So I'll share a couple of examples of how forward-thinking organizations, in this case, such as Nestle or Maersk, are already using digital twins to make multi-million-dollar improvements. So 4 years ago, Nestle wanted to evaluate how various sales and marketing strategies influence their in-store merchandising and economic factors. So what did they do? They basically optimize their forecasting structure. And at one point in time, 80% of their forecast included some sort of human judgment in the form of a glorified Excel spreadsheet. This judgment was filled with subjective domain knowledge that drove a conservative amount of inventory after the forecast was reviewed by multiple layers of experts. So they decided to take all of the factual data collected over time, which allowed them to use lean analytics to drive statistical forecasting with no human judgment at all. During the first year of that implementation, they learned that for every 1% of improvement, in the forecast accuracy, it translated into 2% in reduction of safety stock inventory. Today the tables have turned. 80% of Nestle's forecasts for some of their products are implemented with no human judgment at all, and only 20% still require a certain level of human oversight by their management team. So far, the implementation of digital twins to simulate and trust their forecasts have resulted in 14 to 20% of their safety stock inventory and still meet the customer's demand. So their need for discounting inventory because it's about to expire, it has greatly reduced as a result of using digital twin models, which have been implemented within their operational domain. Another forward-thinking company is Maersk. Although they had a roller coaster year in 2020, Maersk is the largest international shipping container company in the world. They have been using data collected in their IoT refrigerated containers to physically track the environment and the health of the containers to prevent goods from spoiling, as well as track the containers themselves as they navigate from continent to continent. The data collected has enabled Maersk to make more informed decisions and reduce the time spent by their ships at port. As a matter of fact, in an early stage pilot, over a period of 15 weeks, they were able to intervene about 180 instances, which could have resulted in customer claims and millions of dollars lost. So I'll move on here to this next slide. So what makes digital twins effective is its dynamic manner in which it collectively brings all of the data from multiple physical nodes, perhaps in the form of IoT devices, and then communicate a vast amount of data using open standards and APIs so that AI can then compute mega multi-model simulations and feed its results via the cloud onto possibly many end users or perhaps AI models to evaluate and dissect more complex data-driven emulations. Finally, the end users can then use this simulated digital environment to verify our existing physical operation models, or better yet, optimize scenarios that would have not otherwise been attempted. With existing operations primarily in fear of breaking what works today, right? So we wouldn't be moving shelves and racks and so on out of fear of the costs that may influence the change in the physical change in the environment. The good news is that digital twins helps us to trust the end results of the simulations because there are in fact digital threads. And those digital threads, they serve as pipelines from the actual data collected throughout the entire process, along with digital signatures. So we know every handoff along the way. So we know that collecting useful data is important to the success of optimizing processes in the warehouse, especially processes in the form of automated inventory control and safety. So What makes global companies, for this example, like DHL, to have a competitive advantage is not only their ability to pilot emerging technologies to improve operations, but everything is done with safety in mind. I'll give you an example. In some of their facilities in Asia, not only do the forklifts, the pallets, the AGVs, not only do they carry position trackers, but so do their employees. The employees walking around the facility. They also implement heat signature maps to assess areas that carry higher amount of foot traffic. This enables them to improve efficiencies among their daily operational workflows and increase safety. Well, we may ask the question as well, why? And if you think about it, why not collect valuable data while also enhancing the safety of their valuable employees, right? Automation technologies such as drones, AGVs, or automatic storage and retrieval systems not only perform a task while keeping employees from being put into unsafe predicaments, but they also provide sources of signature data threads at continuous and predictive rates, which are then used to validate, emulate, simulate various operational environments. So, for example, our own FlytWare product serves as a form of automation and AI technology. And its data collection helps to enhance digital twin models by providing richer amounts of data in the form of raw inventory scans, images, and videos. Companies can now implement machine learning algorithms to implement, say, 2D, 3D volumetric counts and optimize their inventory while using simulations to compare initial investments against expected results. Better yet, we can now evaluate and report how often and in which locations damaged products are found. This is useful in estimating product yield after its manufacturing process. Let's think about it this way. If your WMS issues a random scan locations for cycle counting, it triggers on autonomous deployment of a drone to go and scan one or more bins, upload results of the scans back to the WMS, and identify empty bins and automatically issue purchase orders for authorization or to replace the inventory as necessary. This is a scenario that we can do today. Or use a set of historical images based on weekly, monthly, wall-to-wall counts in the facilities to build predictive models of how inventory is moved within the warehouse, and allow your customers to view and monitor the condition of their product remotely without necessarily having to be physically present there on site. So long term, this data will become quality data useful for digital twin models to enhance supply chain forecasting, based on consumer demand and operational efficiencies. Although initially implementing digital twin models into existing operations, it demands a certain amount of investment, right? The quality of the data and the secure retention of such data is what differentiates unique optimizational models and demands that all employees, all vendors, all suppliers, they're all playing a role along the way. However, when this is done right, the implementation of digital twins can simply be the differentiating factor of having a competitive advantage in the industry. So for those, say the smaller companies in roles such as raw component suppliers, for example, third-party logistics services, you name it. Not offering quality data from emerging new technologies can certainly be the difference between landing that next great customer or not. So now that we've talked through what is digital twins, and you've got an introduction to this, I'm gonna turn it over to my colleague Ajinka here, who's gonna share a little bit more about our product, our FlytWare product. Ajinka, over to you.
Thank you very much, Will, for walking us through the presentation. Moving forward, I'll give you a short introduction about our product FlytWare. So FlytWare is FlytBase's product, which uses off-the-shelf reliable drones to do inventory scans inside of a warehouse and distribution centers. So the solution is completely autonomous and there is no human intervention required. So moving forward, I would like to tell you more about how inventory drones can help create digital twins. So on the right side of the screen, you can see a dashboard from where you can control the drones. That is, you can schedule missions. And on the dashboard, you can see the layout of the facility where the drone has to do the scans. So this is the exact replica of the actual warehouse. That means the operator or the manager has the bird eye view of the warehouse, wherein they can click on any particular location and send the drones there to do the inventory scans, or they can get pictures in that location from the past missions. So this data can be then used to plan, execute, and analyze stock taking activities in an efficient manner. So moving forward, inventory drones also help to enhance digital twins. For example, since these drones are very cost effective and easily available in the market, they come with an ability to deploy multiple drones inside the warehouse. And since there is no manual inventory scanning, they have the ability to do high-speed barcode scanning. So few use cases and the benefits of these are real-time data. That means the drone can be sent multiple times to do the scannings, and the frequency of the cycle counting inside the warehouses can be increased, which creates the ability to gain real-time data of that particular facility. Also, if the manager or the operator wants to send or do scans of a particular location, then they can schedule an on-demand scans wherein they can just click on a particular location where the drone will go immediately and give the operator the report what was found at that location. And with that being said, the drone's camera captures images and videos, which then can be used, as mentioned by Will earlier, to create some ML algorithms, which will help avoid any dangerous situations or accidents. Also, inventory drones come with a centralized operation platform wherein the warehouse managers or the stakeholders can sit in front of a particular computer screen and they can get an idea of all their warehouses on a single platform without traveling the distance. For example, if one of the company's warehouses is doing really well and other is not, then the operator can do analysis by just sitting at their office in front of the screen, looking at the dashboard. And with the bird's eye view of the solution of their warehouse, it is easier to compare both the inventory in multiple facilities. So one example of how integrating these automation solutions, for example, the inventory drones with existing WMS, is they provide the ability to create automatic purchase orders. Since nowadays the WMS are very enhanced and very smart, the data from the drone and the real-time inventory data can be used to automatically create purchase orders and also do analysis in real time as soon as the data is captured on the drone. And this data can then be used to enhance customer experience as well as to facilitate cost-efficient operations. And to sum up the presentation, the business values from digital twins are as follows. So as mentioned by Will earlier, the digital twins can help people, operators create data-driven decisions. It also enhances safety, as in since the warehouse or the facility is completely automated, the chances of accidents are reduced. And all this together, if in the operations are done clearly, improves customer experience. And digital twins can also help optimize processes before implementing them in the actual real world. Thank you, Will. Thank you very much, everyone. We look forward to your presence in our next webinar. Thank you. Have a good day.